So at the end of the last video, we got to this point. We have two ceramic shell molds. They're burnt out. They're ready to heat up and pour the bronze, which is the part everybody wants to see. And it went well. I have no video of this process at all. So I'm going to go back. I pulled some older videos to show the process. It's kind of the repetitive. And while I was looking for the older videos, I found some shots of the furnace build. I thought maybe I'd show those so you could kind of see how I generate enough heat to melt the bronze. And I definitely don't generate the heat that I did in the beginning because my furnace is kind of wearing out. It's kind of clogged up at the bottom. So my old furnace, which is about worn out, but it's still working, is got the crucible in it, and it is full of scrap. Well, not scrap bronze, but bronze left over from my last pour. This is all silicon bronze, Evador, I believe. I don't use the rescue bronze anymore. So it's ready to heat up and start melting. I gotta wait for my wife or my assistant or my boss, my safety coordinator, to get through with her swimming this morning, and have to hold off for about an hour until I can start heating up stuff. Okay, furnace has been running for, I don't know, 10 minutes or so. It's getting pretty hot. But this is a crucible furnace, and it's probably the least efficient types of furnaces for doing metal work. The flame wraps around the crucible, which has the bronze in it. So the flame never really touches the bronze. It has to heat up the crucible, and then the parts of the bronze that touch the crucible, they get temperature transfer and they start to melt. So with a big boy foundry, you would never see one of these kind of furnaces, but they're easy to make for the home guy like me. However, once you get some melted bronze in the bottom, then you get kind of 100% heat transfer. So that's why I like to put lots of little scrap pieces in the bottom first, and then once they start melting and you get a little liquid in the bottom, then the bigger chunks melt a little quicker, and it's kind of exponential. And we have the kiln on. We're soaking the molds. We're at 1200 degrees right now. These heat up real fast, so at the last minute I can turn up the flame, get them up to around 1800 degrees. And we want them as hot as we can handle them to make sure the bronze flows freely without freezing. It's time for me to go get my boots and stuff on. I don't pour with tennis shoes. I cut all my ingots in half just because it's so much easier for me to handle with the tongs. And my crucible is not that big, so if I try to put a hole in, half of it sticks out, and sometimes it melts and falls over into the kiln, into the furnace, not in the crucible. So got them all cut in half. Got some bronze stacked around the opening, just kind of preheating, no sense in wasting heat. And make sure they're dry, because you don't want to put wet stuff in a crucible. That'd be bad. Okay, so the bronze is melting and dropping down pretty fast. So I'm able to steady add more solid bronze to melt. Let's back way up. This is what's inside the bottom of the furnace. This is refractory cement. I made this. You don't see this normally on these homemade furnaces, but I figure this gets the gas burning and swirling before it passes up 15 to 20% of the crucible. So, and this is looking down from the top before it's ever fired. So you can see the cast refractory at the bottom, and then there's a row of insulating bricks that are soft, kind of chalky. You can cut them on a table saw. Behind the insulated bricks is a 1-inch layer of the ceramic fiber insulation, and then on the top is a refractory cap to hold it all together. In the beginning, there was a groove that kind of linked in the cap and the top so they fit without losing a lot of flame. That's kind of gone away now. It's kind of crumbled. And the black paint, which came originally on the drum, is still mostly there, which is a testament to the insulation ability of the ceramic fiber insulation. This is the burner. I just have a natural gas coming in the side. I have 2 psi feeding the building. It's probably only 1 by the time it gets back here. It's just an open pipe. It just blasts down the middle. I wasn't happy with the amount of heat I was getting in the beginning, so I cut this thing in half. I opened it up, and I put some turning vanes, trying to swirl the air coming from the blower. I'm trying to maximize contact between the natural gas and oxygen molecules. And this is, again, I've never seen anybody do this, but I think it helped a lot. It's kind of a rifling kind of deal. I just want as much air and as much gas that can burn in the limited amount of time it has in the furnace. I mean, I don't know what the duration is between the time a molecule enters this blower and exits the top, but it's not very long, so you don't have very long to heat this to the maximum. And I think these little turning vanes helped. It seemed to help. They're still in good condition as far as I know. What's happened is the volute at the bottom is all clogged up with spillage, so I'm not getting a good swirl, and also the top leaks flame out the sides, so it's probably time for a rebuild. I don't know when I'll get to that. And this is what it looked like in the beginning. And I do have videos of building this furnace and building the burner and all that stuff, but you got to go back several years to see that. Again, most of these clips are not from pouring the piece that this video is about. These are older clips just because I didn't have anything to work with. So, once the bronze is heated to about 2100 degrees, and I judge that from looks and from, I have a little infrared thermometer that shoots it. That lets me know it's time to pour. So I turn the heat down just a little bit so it won't overheat, and we open up the kiln, and at this time we have the molds up to about 1800 degrees. This little clip is from way in the early days before I had my hot mold grabbers hanging from the ceiling. I was just bundling up with cloth and face shield and anything I could put on to keep from melting my face off, and I was leaning in there and grabbing the molds with welding gloves, with ceramic insulation pads to keep from burning my hands, because this heat will go right through a welding glove. So this was pretty primitive and kind of reckless, but we did this for like 2 pours, and then I figured I got to do something different. So that's when I made the tongs that hang from the ceiling, and they work really well. Every now and then I'll bang a piece into the side of the furnace because I get excited and my hands shake and I lose control. I've dropped 1 or 2 little molds, and I've broken a couple of little molds handling them, but 95% we do good with the tongs. Put them on the little table, which is insulated with the ceramic fiber insulation, and roll them to the sand pit. I don't carry them across the room anymore, and we've cut our handling time down tremendously. And handling time is critical because these things are dumping heat by the second. So we're losing heat. We want the molds as hot as possible when we pour, and this was just a bad setup I was using for the first couple of pours. So now I have a pretty good system. The tongs are hanging from a unistrut on the ceiling so they can roll back and forth. I grab the pieces, swing them to the little table, which is padded with the ceramic fiber insulation, and Debbie is standing behind the table with hot mitts, and she receives the molds and gently lays them on their side, which goes really quick. And then we can roll the table around and set the molds in the sand bed. Then the part everybody wants to see. The bronze is hot and it's clean. Pull it out of the furnace. Everybody says this is so dangerous, but really, the bronze is not a carcinogen, it's not explosive, it's not poisonous, it's not unstable, it's just freaking hot. So if you deal with the heat and you protect the bronze from moisture, which is really the biggest problem. I've never gotten the first blister pouring bronze, and I've burnt the heck out of myself welding and grinding and other types of work, but never got a scratch on pouring bronze. I guess I shouldn't have said that. And now for the last couple of years, Debbie has given me an order not to pour by myself. I used to be able, I can pour by myself, but I have to handle the crane controls and the crucible tongs at the same time. She stepped up to the plate. And like I said, she grabs the molds coming out of the oven and lays them on their side, so it's just quicker than me trying to lay them down with the tongs. And she also grabs the crane control buttons, and when I say up she goes down, and when I say left she goes right. And every now and then we communicate, and it makes it another time-saving feature, because it just gives me another hand. She can operate the crane, and we can get this bronze poured into the molds a little bit quicker. So it's hard, it's hot, it's dirty work, but I feel fortunate to be able to do it in this point in my life. So I love this stuff. Maybe I'm just like my neighbor said, maybe I'm not right. Again, this is old photos I dug up. This is the first time we poured this swamp scene, and this was rescue bronze, which was basically melted together whatever I could find. And you could see we had shrinkage issues all the time, and the bronze had a lot of zinc in it, which made it really hard to weld. So I was thinking I was saving money using old bronze, but it really was a mistake. The new bronze is so much better and so much easier to work with. Okay, back to the current project. The bronze is poured probably 30-40 minutes ago. It's starting to cool, and when the bronze cools it shrinks. The ceramic shell does not shrink or expand with temperature, so you get some stresses built up and the molds crack, and that's actually a good sign. That means our bronze most likely filled all the way to the top when you see the cracks at the top. Taking it outside so we can break the shell off of it. Now at this point, you have the bronze arc, you have the bronze pour cup, and you have all the bronze feeder system, and you have the ceramic shell. So it's pretty heavy, and it's still really hot. So that's why I have this little hook. It's built this just to handle these molds. I got a little bit of no flow up in this corner where it froze before it got all the way up there. I don't know how big a deal that's going to be, but a little disappointing. So I know it's hard to tell, but the first one, the surface is like perfect. Just got that one little spot that didn't fill. It froze before it filled. See if that makes a difference or not. Let's bust the second one open. Hopefully it came out just as good. Second cast came out just as good as the first cast, maybe even better. No voids. I'm going to start the process now. Cutting off all these screws and getting down to the cleaning the back up. We'll cut all the little ones off, then I can finish chipping the ceramic shell and then cut those feeders that are in the middle that I can't get to right now. I'll get to them. This will be easy. As easy as it ever gets. So why did we get a void where the bronze didn't fill the mold at the top little upper corner? Obviously, it was temperature related because the bronze froze before it flowed all the way. In the words of my grandson, who is 4, I don't know. Could have been that the bronze wasn't hot enough. Could have been the molds weren't hot enough. Could have been I poured too slow. Could have been this was the second one I poured, and by that time we had lost another 50 or 60 degrees of temperature. Could have been I didn't have enough sprues. Could have been those little sprues that I didn't like using in the first place. Could have been the pour cup wasn't high enough above the arc. Just so many variables, but after we get it cleaned up and looking at it, it's really a very minor thing. It could have, I've had pours that have gone much worse. So I'm down to the last few cuts. It's kind of cool. You can see the different layers of the shell. Every time I dipped, it leaves a little growth ring like a tree. I got a pile of ceramic shell, which goes in the garbage. I got a pile of cut up sprues, which I will melt again the next time I do a pour. I got a worn out wire wheel where all the wires mostly were in my arm, in my shirt, which I'll probably have to throw away. And I have the 2 casts, and they look pretty freaking good. I'm gonna put them in the bead blaster and clean them up. Do a lot of bending, because see, it's kind of warped, but it's thin, it'll bend easy. Got to turn it over, finish grinding off where the sprues were attached so it'll sit flat. And yeah, pretty happy with this. And the little part that didn't come out, I think was right here. But I have the mold, so I can pour a wax in it and compare. But I really don't think the owners, I can pour that little corner only and then weld it on. but I really don't think he'll care or want to wait another 2 weeks. So, but it'll be his option. We can make it right if that's what he wants. Okay, quite a bit of grinding later, and I'm ready to weld the two pieces together. I got a good fit, and I got the weight keeping it immobile. Get the TIG machine fired up, and we'll weld a little bit in the front, a little bit at the back, and gradually fill it with weld. So I took the big boy grinder and cut up some of the sprue from this pour into some little plates to give me something to work with. And I haven't checked, but I promise you they are hot enough to burn your finger. We'll put them in the water. So I did another little splash cast of wax in the original mold so I can see what I'm missing. And I'm gonna, it's not very much. I'm gonna slide this under the bronze, and I'm gonna mark it on the table, and then I'm gonna build out to where it was supposed to be, and I believe I can capture the finish. I think I've done pretty good so far. And just weld new material, and I'm gonna use this bronze, which is from the original cast, so it's gonna match, should match perfectly. So it turns out I'm dealing with this in a totally different way. I put a scrap of a bronze sheet. It's a different alloy, but I put it underneath, kind of act like a heat sink, and it ended up like brazing together. So I just built all this area up by pad welding the bronze, and it kind of stuck to that sheet. So I just trimmed that sheet off, and now I moved the sheet over to catch this little part. Catch this little part right here. Everything's really hot. And then I'll cut the sheet and leave that there. And when I round these edges over, I'm gonna be done almost. I need a little bump right here. And this is going good. And if it doesn't look good, I can always cut this whole square out, take the wax and cast another bronze and weld it in. But I don't think that's gonna happen. I think this is gonna be more than satisfactory. It's taking a little while, but it's all right. So in the back, this is what the owner wanted. He wanted a hanger and another offset to hold it about an inch and something away from the wall. We did that. We are very close to being through. Check it one more time. Look around for boo-boos. And then we'll put it in the blasting cabinet, and that'll bring it all to a dull finish like this. We'll be ready for the patina man, which is not me. He has somebody else coming to patina. I didn't show the chasing process. That's how you make the welds blend into the sculpture. I use pencil grinder, hammer, chisel, needle gun, whatever you call those things. I used a little bit of everything, just beating it with a hammer to just get the texture to match more like what the original texture is, and it's one of my better jobs here. Yeah, you're going on YouTube.
All right. Hello, tubers.
So Michael is finishing up the patina. He started at 8, 9 maybe?
9 o'clock.
And it's noon, so until 11, 3 hours. That's kind of what he guessed.
That's about what I guess.
This is Jim, the artist. Say hello, Jim. Almost done. We'll put a coat of wax on it to kind of seal it all up. Right now he's using, what is that?
Silver nitrate.
Silver nitrate to give these white colors to the moss. Pretty cool. I've never used silver nitrate before. So this is not paint. This is a controlled tarnishment of the bronze. The greens come from cupric nitrate. The browns and reds come from ferric nitrate. There's also sulfurated potash, and has a slang name that most people use, but I can't remember it right now. And a silver nitrate and good old tree wax, which has been a staple for patinas for 100 years probably.
Thankfully, they still make tray wax.
And the last step is to wax it up and then buff it out.
That's pretty.